Hello and welcome to Lands Unknown. My name is Will, and today we are going to begin doing the close climate study of Zaalea and looking through the variety of climates we got there. We're also going to look a bit closer at the topography and the islands and things like that as we go through it. But I'm just going to start like I did last time, talking about why I picked the projection I picked. Hello, Ian. Welcome to the stream. And Kate. Hello, Kate. Yeah, it's going to be quite similar to the other one. Luckily, though, we already have a bunch of stuff done. Hello, everyone filtering in. And since I already, decided that I'm going to use an equal area projection, I grabbed the regional map from last time and stretched it over. So don't have to worry about doing that stuff. So doing the outline later in the live won't take too long. This live also may run a little shorter, and that's just because the charger is AWOL. So just running on battery for the moment. So we'll see how long that lasts for. But, we'll probably get a good hour out of it or so. And that's on me. Hello there, Writer 2. All right, so let's just dive in. Excellent. Got us. How do I... All right, here we go. So let's take that away for a sec. So here we have the orthographic projection, and this is just kind of zoomed in to what we're specifically covering. Hey, Madeline. And for the equidistant and equal area, this is primarily what we're interested in here. So you can see that the corners are going to be more distorted. And hello, Jake. The corners are going to be more distorted, so we don't necessarily need to see those when picking the projection. But when we flip between them, you can see that in the flattening, there isn't, too much distortion here from the equal area. For the equidistant as well, very minimal distortion. I think the one thing that I was looking at was with the corners, you can just see some of the, we can't really see much of the corners anyway. But when we switch between these, if you look at the edges, like, where's a... Like, if you look over here, then you can start to see how the equal area distorts it, as opposed to how the equidistant map distorts it. And so there's a little bit more stretching with the equidistant in a way that I don't find aesthetic. Again, this is just about preference, because the main area I'm interested in is more or less the same, right? Like, it's not all that different, but I do prefer the equal area for this. I spent a bit of time choosing what I was looking for. So now that we've got that out of the way, I'm going to put those in a different group and drop them down. I'm going to dump the orthographic into there as well, just because we're not going to be looking at these all too much. No, I don't want another new group. The audacity. It did do it again? It did it again. Okay, well, not my problem. Okay, so let's drop the elevation below. So we've got the elevation map like we've had before. And I can throw that on top just to see kind of what we're working with here. I may stretch that out a little bit later. It should curve a little more, but that's all right. Going to be working on that later. Yeah, it's good that we're keeping the distortion to the minimum. Just, and Zaalea is maybe a bit of a difficult continent because it stretches from 0 degrees to like, what is that? 0, 15, 30, about 45 degrees. It's also very thin, or at least the parts I want to look at are very thin. So getting getting a projection that isn't just the orthographic projection can be a little annoying because it is like long. The one that we used, the Albers that we used for the Tyche, if we wanted to use that for Zaalea, it would have just stretched it and made it look wider than it is. So yeah, whenever you're picking a projection, you can go into G Projector and upload your original map. Just, tool around and look through all of the different projections just to find one that really lets you highlight your region in the way you want it to be, like the shape of it, in particular. Yeah, the other thing I may do is just kind of cut off a bit more of Arukia and stuff from the side of the canvas, but I'll get around to that because I feel it goes a bit too much. Yeah, like, I don't know, cutting that maybe useful just to frame Zaalea a bit more. Because for the regional map, I mean, it doesn't have to be any particular size. The other thing I may consider is shifting it to get that in there. Yeah, but that'll be for next time. Yeah, there are some really weird ones out there. And I think, for Dove, for Basera in particular, like showing the whole thing, I think there's some good ideas. I have some good ideas for doing that because it is, largely in the northern hemisphere. So you can pick certain projections that just show a hemisphere and get a decent amount of Basera in with like minimal distortion. It's a very neat. And I going forward, moving away from Mullwide or Robinson and stuff like that would present an interesting perspective, especially from the Dovians who, by and large, live in the northern hemisphere. So, like depicting them as in, the Western Hemisphere or having like a global projection that prioritizes the Southern Hemisphere in any way, could be something that they don't really care about. Like, oh yeah, there's like some islands. Yeah, so that would be pretty cool. Oh, and I think other big news, we actually have a date for the World Building Festival. I believe it's September 4th to 6th. So I think the same weekend, the first weekend is in September, the same as last year. So that'll be exciting. I'll probably put out a, call at some point for the things that I'm going to do. I have some stuff in mind. I'm going to reach out to some of the other folks who are participating and do some collabs, but I also plan on doing my own thing as well. I think last time I did the chariot lecture more or less. So, if people are interested in seeing something in particular, you can sound off over the streams or leave a comment. No, I'll compile a list and maybe I'll have the patrons or folks on the live stream vote at some point. Okay. So getting rid of that for a sec. Yeah, I do want that to be a little bit lower. So we may see a bit more from the other side. That's okay. So from the elevation, just looking at this as we start off on the base on the, Eastern no, western side. Ugh, the Tyche Basin was my reference point last time, so now this is my reference point. Let's get into it. So on this side of Zaalea, on the western side, we have the Metredis, and the Metredis are the youngest orogeny of the, what is it, Zaalean Cordillera is what I've been calling it. And it's being formed as the basin slowly subducts under the Zaalean, under the Zaalean plate. A lot of things to remember. Does the G protector do oblique Mercators? I think so. Do I have my computer here? Yeah. I've got my other computer. I can check. It does a lot of them, I have to say. Some of them I don't find particularly useful, but it does have a lot. All right, well, that is getting into gear. So what we're going to be noticing in this map in particular is, let's make that a little bit bigger. We are going to be seeing, we're going to be seeing a lot of the precipitation coming in this way, and it's going to slowly rise. And as it rises, of course, it is going to cool, and as it cools, it's going to condense. So we're going to see some, even spread of moisture. Of course, the places near the coast, especially these tropical areas down here, are going to see the most precipitation. But we aren't necessarily going to see deserts in the same way we do in other, coasts, right? And this is also on an eastern coast. Eastern coasts tend to be more pluvial just from the way that high pressure systems tend to impact them. We do have this area, which sees largely parallel winds. Depending on the time of year, there will be times in the spring and the autumn where it receives precipitation. But, if you're receiving 600 millimeters on the equator, that's not a significant amount of precipitation. So, it's going to be, or even 800 millimeters on the equator with how warm it is there. So, probably going to see that's why we have the BSH climate. The other place we're going to see a decent amount of aridity is in here. We've got some long valleys that are BSK largely. And that's just because when we have this sort of setup, what happens is the precipitation hits here, rises, condenses, and rains. And then as it moves over here and it drops, it's going to expand. And, because pressure nearer the ground is tends to be higher than pressure further away from the ground, it is also going to be warmer. Warmer air can carry more precipitation, more moisture in it. So we're not going to see as much moisture here. And then we're going to see a bit more moisture when it hits there, nothing in there, and then a bit more when it hits out there. So we're going to see an increasingly arid valleys along here. But the one thing with that is that these are going to be relatively higher elevation. So, we may see some BWK, but for large cars, it's going to be BSK. That's a lot of water. It is a lot of water, though, depending on the average. I mean, if you look back to the footnotes video, where I did that comparison between London and Ouagadougou, right? Like Ouagadougou gets 812, something like that. 812 millimeters, and London gets like 612. So, but the difference between a humid C climate and a dry B climate is the annual temperature, right? The amount, which is a proxy for potential evapotranspiration. So the places immediately north and south of this area are being hit by a lot more precipitation, and they're getting, you know, thousands. They're at least getting like 1,000 millimeters. Though I think for a lot of contemporary Köppen, when they're thinking about the aridity, uh, the the maximum amount of annual precipitation that a place can receive is without and still be an arid climate is less than 890 millimeters in a lot of versions. So if you have an if you have a tropical climate and under the current climate regime, it receives 890 millimeters. It's going to be an A or a C climate. It's not going to be a B climate. But if you get 889 millimeters, it has the potential to be a B climate. And again, that's just from, looking at, yeah. I don't know how that would work on other worlds or hotter worlds is definitely, a stretch of Köppen as it currently exists. Yeah, let me check a G projector real quick. I think I got it up. Yeah, it doesn't look offhand like it has oblique Mercator. Got oblique Hammersmith and oblique Itoff. Oblique Equirectangular. Oblique Molawide. Yeah, it has a handful of options for an oblique map, but the one I have at least doesn't have Mercator. Um, I mean, they may have released newer versions that have more maps, but sorry, I was speaking off to the side there for a sec. But yeah, no oblique Mercators in the one I have. So there may be other ones that have oblique Mercator. And I've got that nice coffee again. It has like a juicy berry smell to it. It's wonderful. Oh, Chariots Part 2. Yeah, that'll be. Well, once I get more into domestication on Dove, then we may have something there. Yeah, and then as I had it before, if we look here, in this area and in that area, we've got W climates. And I will bring up the... Yeah, I'll just bring that up now. Why not? Okay, so in July, we have a lot of precipitation coming up from the Aphrodite. So we've got a lot of precipitation coming up in here and coming over here. There will be a bit of a rain shadow from those mountains there, but we've still got channels between those valleys for some unique precipitation to come up, and it'll also be going up there. On the other hand, we've got the precipitation coming straight this way. However, we start to get, a few thousand kilometers in, we're going to start to lose a lot of moisture in the air. And that's what, no, sorry. We're going to get a lot of precipitation coming in. This is the summer. So we're going to get a lot of precipitation coming in there. We are going to see some drop off in precipitation from the distance it's traveling. But, we're going to see a decent amount of precipitation in this region. But the reason why these are W climates and not S climates is because we've got the Zaalean Cordillera and the Metredis, and they are blocking precipitation coming off of the Tyche. So if I bring that back up, get rid of that for a sec. So if we look in this region and this region, there isn't any significant moisture that's able to make it over those mountains, over those ranges. And that's why in those areas, we've got the W climates. So in some areas in that interior, especially this northern interior here, there may be less precipitation than one would expect for a W climate. But the thing is, they are cold enough not to be a B climate, and they receive significantly more precipitation in the wettest winter month than they do in the driest summer month. Interesting to see how arid this peninsula will end up being. Oh, which peninsula? This one? I don't think it'll be very arid. Okay. So yeah, so this is the general. So yeah, we've got these cold arid regions in there. We've got this strip of W climates in there. And then we've got a brief W transition, or is that an S transition? That is an S transition. We've got the central portions of landmass. Yeah, it will be interesting to see how arid they get. I mean, in the north, it is probably going to be a like a wet summer taiga, essentially. So you're going to have I don't know, what are they called? The spire metamorphflora, the spire plants growing up there. And they tend to grow in more arid regions, but they do well up there because they can conserve a lot of water. Well, we could call Eastern Basera a peninsula, I suppose. But on the grand scale, everything's a peninsula of something. So yeah, so we're gonna probably see a lot of those spire trees and other creatures that are and other plants that are adapted. So probably some forest up there, but largely we would see shrub and herbland, just because with the lower amounts of CO2, we are going to see smaller plants and things. And in the south, though, it is going to be warmer, so I doubt we're going to see. The south is in a similar situation here because while it will receive much more precipitation than the northern wet summer region, it's also hotter. So plants are going to have to transpire more to be cool. And in order for that to happen, it's it have to transpire more to be cooler, and there's also less CO2. So we're probably also going to see dry forests, copses of trees, probably riparian forests, gallery forests, that sort of thing. And um, generally, though, it's going to be a savanna. It's going to be a wet summer savanna, which is, new thing for the channel. Because normally we talk about wet winter. So, and then the other thing here, um, Basera does have a monsoon effect, right? If we go back to where we go here, great. So we do have the oscillation where we have the low pressure in the summer, and we have the reverse in the winter, coming from this Palomian high, primarily on top of the ice sheet. And a lot of the methods for modeling climate that I see. Oh, yeah, very quickly. Metamorpho is an interesting idea, clay based around genomic plasticity, if I'm understanding this correctly. Yes. A lot of plasticity. Well, the plasticity for each of the species is largely physiological. I mean, they do trade genetic information with one another through grafting together when they, become trees, when different shrubs from different organisms meet up. But yeah, the plasticity is still physiological. But what happens is that when abiotic conditions are suitable, they can shift from the same individual you know stem, I suppose, if we want to use that term, can transition from a herbaceous plant to a shrub, and then from a shrub to a tree. Can't go the other way though. But usually the organism is much larger, so each of the stems that it may have, can change through its lifetime to kind of adapt. Or for the rhizomic ones, the rhizome can grow and expand, and then have different shoots and stuff like that. But I do like the plasticity. I was a big fan of that. Cool rainforest fog in the morning. Yeah, I love cool rainforest fog. So something that I see happen quite frequently with world building when we do climates is that the eastern coast tends to be very, especially of larger continents, tends to just be dominated by W climates. And this is usually because that certain factors aren't taken into consideration. Usually, it's just you just drop the high pressure system down and it evacuates all of the moisture, even from the coasts of the continents, like the eastern coasts. If we look at a climate map of, can I do that? Yeah, there we go. Okay, there we go. Great. So if we look at a map of East Asia for Köppen, there we go. We can see that a large portion of China is CFA. And we can also look at Japan, and we can look at Taiwan, and we can see that the eastern sides here are all F. I mean, Japan more so than Taiwan down there, which has a W region in it. So and there are reasons why this is happening. One is because the high pressure system has southeasterly winds coming off of the Pacific, and that is going to cause precipitation during the winter. And in the winter, you also have storms. You have low pressure systems moving along the western side of the Pacific, starting at the north and then moving south along the west coast. And that, as they move along from here down to here, cause storms and things which bring moisture into the landmass. So if we look at here, the parts that are W, especially in the west and in the north here, are further away from the ocean proper. And sometimes the difference here between this F climate, I think we looked at, what was it, like Hunan or something before. But the difference between the CF can be, and the W can be just, a handful of, just a little change in precipitation. I was going to say handful of water, but that doesn't, unless you're cupping your hands. And then up here, we have Japan, which is right on the Pacific. Meanwhile, we've got an inland sea separating them, and while there can be a fetch, by this point, the high pressure system is moving wind generally away. It's got westerly winds, northwesterly winds moving off of the coast. So we don't tend to see as much in the north there, which is a little different on Zaalea just because of how things are organized. But when you're working on your own climate maps for the East Coast, you want to keep in mind these, let's look, yeah. You want to keep in mind this circulation here. So, this area is going to be an F area. Meanwhile, this area in here is going to be W. So I may have to expand the W area a bit. We will see. And as well, we're going to get some precipitation in here because this is going to push precipitation this way, but it's going to be dry in there. And this peninsula that comes off here, which has a Palomian and a Zaalean side, is going to receive precipitation from this way, much like how, Japan gets precipitation from that marginal sea as well. So that's the one part of it. But then the other part is low pressure storms that originate here move down the coast. And as they move down, they are going to be kicking winds this way. So through that, we are also going to get precipitation along the eastern coast of the landmass. So if I just, decided that this is high pressure, therefore, this is the movement that's going to happen, then, the only places that's going to get precipitation in this case are going to be here and in here. But that's not what we see. We see a couple other factors that influence how this precipitation happens. So that's why the whole coast is not just W, right? So we've got the low pressure, and we also are considering the high pressure winds coming off of the Aphrodite. How am I doing for battery? 22%. Oh no. Oof. Yeah, we'll probably make it just for another 20 minutes or so, but that's okay because we're just gonna go over the considerations. And then I will do the outline for the rest of the week, and then we'll start mapping and maybe adding in islands and stuff like that. But hopefully start doing the climate mapping on next week. Everything from on my setup side went very well today. I'm connected to the internet properly. I started on time. I got everything stood up. I've got my mic where I like it. But the charging, the actual charger is AWOL. So sorry about that this week. All right, and then I also want to look at temperature. This will be the final bit here. Not the final bit, but you know what I mean. All right. So, in July. All right, so in July, we've got... All right, so this color in here... no, I need to pick a different color. Let's pick something green. I don't have any green in this map. So in July, this area is 18 to 12 degrees. No, 24 to 18 degrees. So that's good. And then this area here is 18 to 12. And a decent amount of this is due to the shift in elevation. So we see the transition from about 250 here to 500 up where this light green starts. And then we do also have a slight decrease in the summer in these areas as well. And that's just because of the elevation from older mountains, like older orogenies that have been uplifted or uncovered or rebounded through a variety of processes. We've also got the Cordillera here, and we have a steadily increasing elevation, so we are also going to have lower temperatures in the summer over there. And so Zaalea, is relatively warm during the summer. It is certainly cooler the further you go north when compared. It's definitely warmer in the summer when compared to the Tyche Basin, and that's just because we have this very hot tropical, tropical water being brought in to the system. Meanwhile, in January, things get a lot worse. Oh yeah, well, thanks. I figure my first 20 or so live streams aren't going to be that great until I figure it out. So everyone sticks with me from the beginning will be an OG. An original geographer. Okay. So we can see how distinct that it is in the winter. So summer, winter. Yeah. And one of the reasons why that these cold temperatures are allowed to get so low is because when we have the seasonal shift, the tropical jet of warm water is further south, which insulates this area in here, but it also very clearly limits where the tropics can be, right? Like the tropics are quite limited to this area. And just because of how the low resolution of this works out, I do have some creeping up in here, and we've got some tropical regions in here. This will probably be something in this regional map we'll look closer to. This is like what happened when we were in the Tyche Basin and we saw some of the AW creeping up into the into that pointy terrain that came down. Yeah, super stark. So we're going to see some of those changes. We can also see in here that now I'm working with green. Great. We'll see in here how much of an impact those raised areas have, kind of moving some of that sea further south. And then we have this highland sea area in here as well. So just kind of breaking up those A regions. Now, at the moment, a lot of this is F. So we'll come back and review that. We also have a very thin monsoon right there. So I'll probably come in and widen that out. Probably move it further that way. And what I also like here is that this is an AS region. I think that's the only sort of Mediterranean area is kind of right here on Trans-Metrine Zaalea, which is fun. You know, it's nice to have variation throughout the world. Getting back to here, places that were '18 in the summer. And even down here, which are 24, in the winter become super cold because this is the 0 line here. And then that is -6, and then -12 is up there. So we go from 18 in the summer to, I don't know, -9 in the winter. So huge shift. This is where we start to see the D climates, you know, those continental microthermal climates. Meanwhile, down here, a place that has a very balmy tropical summer, 24 degrees. Now, there's 6, 12, 18, is now on the 12 line. So this is why I think in the couple folks remarked upon it when I mentioned it in chapter 1 of the Spec Atlas. But in the winter, well into the tropics, because this is 0 degrees, this is 15 degrees, this is 30 degrees. So the tropics are like here, you're getting snow, more or less at sea level. You're going to get snow. Oh, what do we got here? This Celsius? Yes, I'm always going to work in Celsius. I have very few geographers work in Fahrenheit. Even those in the States tend to work in Celsius. How much? Okay, my brightness just dropped because my battery is... I'll turn it up a little bit. All right, 14% battery. Let's go. Yeah, always Celsius, default Celsius. Oh, no, that's latitude. These are Celsius. There we go. On the winter precipitation thing, don't winter storms usually travel west to east and more the coast like winter storms do in the US? Or is this a different phenomenon? So, yes, we are going to see winter storms. Yes, we're going to see two kinds of winter storm. We are going to see those kinds where, let's get this out here for a sec. So, two kinds of winter storms here. We are going to see some winter storms where cold, continental, So we'll see cold continental air masses, which are just CC for now. Cold continental air masses which don't have, that are dry. So cold, dry air masses are going to be coming in from the northwest. So we're going to have northwesterly winds. And these are going to impact with warm maritime air masses. So, we got maritime and they are going to be hot. Or just to match the other one. And so when we have these cold air masses overtaking these air masses, we are going to see some storms coming out of this direction. We are also going to have those low pressure systems moving this way from the east, and they are going to go this way or this way. So that's going to be the easterly traveling winter storms. So we're going to have the ones starting from the west, which originate from here and here, and we're going to have some storms originating from the east, moving this way. Yeah, there are going to be two kinds of storm systems in the winter here, and this one, obviously, this area is going to be more impacted by the west to east kind of storm. But we are going to have east to west storms, which are going to be more impactful here. Another thing, we're going to have fawn winds due to the Metredis. So we're going to have hot, dry winds moving down there as well. So we're going to have a lot of different storm systems and air systems moving through. I need to double check the notation for hot and cold air, maritime and continental air masses, but that'll suffice for now. Boop. That's a good question, Elta. Thank you so much. And I've seen you a couple times before, but good to see. The 18 to -6 spot is similar to where I live. Though this is probably much further south than where you live if you drop your latitude in the comments, because the 18 to -9 spot here is like, I don't know, around 37 degrees latitude. Yeah, about 37 degrees latitude. So we're gonna regularly see snow down in the tropics. We're gonna occasionally see snow down in the tropics in the winter, but regularly we're gonna see snow at about 26 degrees latitude. That's going to be pretty interesting. We're also, and we're going to have regularly, as I mentioned before, we're going to have cold air flowing down from the higher elevated areas, just from the adiabatic cooling. We're going to have, those, we're not going to have there's not significant glaciation on this side of the Palomars and the Metredis. But that is also because during the summer, we've got really warm temperatures reaching up there. Roughly 44. Yeah. So we've got it about, what'd I say? Yeah. So almost, 8 degrees further south than that, which could be quite fun. And that's just on the fly. Any advice for if instead of reconstructing one of present condition of your planet, you want to reconstruct the planet's history? So what I would recommend, and I did very quick versions, is if you do your deep histories, I don't have it on this side. I have it on in a different file. But when you do your paleo history, you can do quick and dirty climates for each stage. And by doing that, you'll have a better idea of the temperature and the relative aridity of different regions so that you can see different realms and how the climate would impact those realms and the movement of biota across, the kind of biogeography. But you don't need to put as much effort into it as you would like a regional climate study. I would just focus on the broad distinctions. Like you could even do one where you're like, oh, these are A climates, B climate, C climate, D climate, E climate. And then within, A, you could just care about whether it's AF or whether it's not. Similarly, for C climates, you could just care whether if it's CF or CW or whether it's CS. And D climates, you would care whether it's DF or you care whether it's whether it's DF or not. Like you don't need to go into the same amount of granularity in the climate zones as well. We are at 6%. All right, let me see if I can get through the rest of what I want to get through. All right, so yeah, about 36. So yeah, about 8 degrees. About 8 degrees further south than Rider 2 here. So, and I think Linnea is a bit more pronounced. I think the colder temperatures get further south on Linnea than on Zaalea, just because Zaalea is thinner, so the continentality isn't as pronounced. So we're going to have the D climates starting around there, which I think I did in the other one as well. Yes. We're going to see some variation where the D climates start, just because of the going in and being more precise with elevations. So this is something that we saw on the Tyche Basin, especially on the west and east coast. Where we were quibbling about where the D climates, the microthermal climates, were going to start. And oh yeah, and then the other thing things we're going to keep in mind is where the glaciers are. And here I don't have the ice sheet on the Trans-Metrine or the Trans-Polomian side of Zaalea. And as I mentioned, that is because we do have a lot of the warmer summer temperatures getting to higher elevations. We'll still see glaciers, right? We're still going to see EF climates, but they are not going to be ice sheets. We can see ice fields, and we're going to see individual glaciers, similar to here. Like in this region, we've got ice fields in there, but it's not like an ice sheet proper. And that's something we can expect in some of these ranges up here as well, though they may not necessarily. But the issue is that they don't necessarily get cool enough in the summer. Some of them do. This is the 0 here, and if I go into some more detail, we may have some in here. But that's kind of going to be the extent of it. We're not going to see the same degree of glaciation on Transpalomine. Yeah, sure. Transpalomine Zaalea. And yeah, and some of this, so as I mentioned before, some of the changes that we can expect to see when going into more detail is the the borders of this A region are probably going to change. I mean, there's probably going to be A sneaking in down here as well. We may have A going along the coast here. Just to, kind of link it together, though, and I'll probably limit some of the cooler temperatures to being further away from the coast, right? So we'll probably see A going all along here. But there are instances where we do have a breakup of A climates. I'm specifically thinking about the southern part of Brazil. We have some A regions that are separated from each other. So when we go in, we'll see what that looks like. I'm going to, see if maybe we'll get some aridity in some of these areas, but I am quite skeptical of that just because of how cold it gets. And the average temperature, if we throw this back up, even here is 0 in the winter, and it's going to be between 24 and 18 in the summer. So we can say about closer to 22, I guess. But that's an 11 degrees as an average temperature, and that you need to receive quite little precipitation with an 11-degree average in order to be a B climate. When we move through that, I'll make sure I have the little plot from the the footnotes to chapter 1. If you want more information on that, footnotes to chapter 1, I have the little plot that shows the relationship for Köppen between the total annual precipitation and the average and the mean, monthly average temperatures over the year. So quite skeptical, but we will certainly see aridity in here. And the extent of that aridity may change. We may note that, the aridity here also shifted as we looked a bit closer. We extended it further north. And we also changed where the S climate transitioned to an F climate right there. So then looking at this area, we may see a shift as to specifically when the BW and the BSK climates start. We can also see whether they'll sneak out there a bit more. But that will, of course, depend on the elevation and how we, go through counting that as we move in. Yeah, and I'm excited for it. I am currently, what are we at? 6%. Okay, and we've got, we're almost at an hour. Cool. Yes, it will be very cool to see the B climates in there. And I think I'm going to call it for 11 my time. So usually it goes for 2 hours, but today we're going to end it after an hour. Next week, 2 hours as usual. And it's going to be a bit of a different setup because I got a new desk, no more glass desk. The new desk was a long time coming. New desk was a long time coming. And I'm going to put it here, so we're not going to see the angled bookcases anymore. We're going to see them flat on. So yeah, so that'll be a difference with next time. I've also been talking to Biblaridian about doing streams together after Zaalea is done. And that'll also be, I believe, after or around the time that Chapter 2B comes out. And we are going to be developing the clades of the terrestrial creatures that live in Zaalea. They're not going to be the monotrematoforms, and there are going to be draconiforms. So the Zaalean dragons are related to the Arukian dragons. So we're going to see different kinds of blue and black and green and all the other kinds of dragons that we'll be looking at. But there's a different group of terrestrial ones. Oh no, I'm starting to fragment there because of the power. So yeah, we're going to see some different terrestrial critters. There's a different group of animals, fauna that survived in Zaalea and came to prominence. So that'll be fun to look at. I'm not sure if I'll do those streams on Saturday in addition, or if I'll just replace the climate streams for a month or so. Yeah. And I believe I'm going to be on Madeline's channel in April, probably. Yeah, April 22nd. Talked about this over on her stream as well. So on April 22nd, I'm going to be on Madeline's channel, and I'm going to be talking about the world building in her new book that's coming out on April 9th, I think. I want to say April 6th, but I believe it's April 9th. Because the Beasts came. So we're going to be talking about that on April 22nd, and I believe it gives a few weeks for folks to actually read the book who didn't get an advanced reader copy. So that'll be a fun time. I have another thing that I was planning on doing with Biblaridian, but I will keep that to myself for now. And then the other thing I mentioned, the World Building Festival. So folks who are interested in the World Building Festival and have ideas, let me know in the comments. That'll be pretty cool. I'm going to do, I think I'll do one lecture styled one, but then the others are going to be more like workshops and fun things, like working through problems. And I'll reach out to Jake and a few other folks to see if they want to team up to do some geography stuff. I think that could be quite fun. Otherwise, if you haven't already, you can like and subscribe. Over on the Patreon, we've got updates coming out every month. Depending on your level, depending on your level, you'll be able to vote on one of the videos that I do each year. And I think I'm going to start that in April, start that process. So that'll be cool. But at the very least, you get to see updates behind the scenes. You get to see sketches of stuff that's coming for future videos, and some of the flora and fauna get revealed in advance with the paintings. And at the highest tier, you can see a video about, I don't want to say a week or so, but 5 days or so before the next one comes out. I think I would have released it sooner, but I had some issues with the encoding process. It was supposed to take half an hour, but it ended up taking 9 hours. Or my expectation was that would take half an hour. Anyway, thank everyone so much for coming and watching. I know this was a bit shorter than it usually is. Next week it'll be back to usual, and I will have the silhouette, the black silhouette of Zaalea done, so that we can just jump right in to climate mapping. And I think we're going to start, maybe we'll start on the E-climates and kind of work our way south. That could be a fun change from what we did with the Tyche Basin. So thanks everyone for watching, and I will see you next time in Lands Unknown.